Welcome to Matrickz Tech Talk. Today we have a very special guest, Professor Rolf Jung, holding a professorship at the University of Applied Sciences, Kempten. He has 20 years of experience in functional safety. He worked in the industry in the domain of automation, automotive, agricultural machinery, and a lot of work experience in testing. He is a TU Munich alumni, which glues us together. We're both TU Munich alumni. So Rolf, welcome to Matrickz.
Thank you, Hassan.
I will then pass it over to Rolf to tell a little bit about his background, his work, his passion.
Well, after finishing or graduating at the Technical University of Munich in physics and physical chemistry, I started at the DIN in Berlin, the Standardization Institute, and I found how to work with these standards. And after that, I went into a deeper work in gas measuring computing. That was the thematics of my thesis, 96. I started to work at a company that produced electronic control units for especially machinery, the conveyors and agricultural machinery. And in that time, the functional safety began to rise. So all attributes in these cars, and also especially the electronic control units, had to be established with requirements from functional safety. But the standards haven't even risen in that topic, and that's why I began to start to dive into these standards that dealt with functional safety. By the time and by the years, I found out it's not just walking through the standard, like the VDE standards, but to work together with all vehicle builders and builders of the electronic control units to see what is the best way. You have to find a compromise between the quality requirements according to functional safety, between the costs and the time that can be done. As soon as you have this standard, as you have achieved this standard, then you can take the effort and put everything into getting everything into a large variety of electronics. Because if you do a electronic control unit, if you build that control unit, then many companies would apply that control unit, put that into the vehicle, and everybody has different requirements. So there's a lot of variety, and you have to do the management of functional safety for each unit themselves. And if you introduce it into the cars and the vehicles, then you have to do the complete process by its own. So a main thing is to do a economical management and find a way of the architecture to get the functional safety easily built into the system. Mm-hmm. And this is a thing that I've been doing now for about 20 years and try to get this into the minds. And since 2015, I'm now professor at the University of Applied Sciences in Kempten and try to get this knowledge into the minds of our new students.
Fascinating. So you've mentioned very exciting points that functional safety just got started, so I definitely am going to come back to that and ask you questions about how was it before, and you mentioned about time costs. So before we go into those two topics, wanted to ask you about the master program that you've just mentioned. How close is your master's program to the industry need? Are the students right away ready to work as a functional safety engineer? Do they need industry experience? How close is the gap, or how far is the gap?
I work at the University of Applied Sciences, and we have the aim that the students work very close to industry. We need security to fulfill functional safety. And that's why we work, for example, together. And Hassan did already give some guest lessons in my course of functional safety and taught the students what is the newest impact in security that they need for industry. And so I do have more experts in other subjects, for example, testing, requirements engineering, that I introduce in the courses, and we try to get the students to a newest stand in industry.
So you try to minimize the gap as much as possible. Your students get the basic knowledge that's required to work in the industry. Hence, you still think that is not sufficient. They need work experience. That makes sense. You try to minimize the gap. So what we have been observing from the industry point of view, that there is a shortage or scarcity of good functional safety or even security engineers in the job market. So from both academic and also from point of view of a company like us, what do you think we can do to motivate more youngsters to join this field? And do you feel that shortage in the market from an academic perspective? Do your students feel that?
Well, we have several master courses, and I offer this subject of functional safety in the two master courses, Advanced Driver Assistance Systems and Automation and Robotics. The students in these courses, they have already done their bachelor and often worked in the industry. And they are very eager in these courses to not only finish this course, just to pass it, but to do it with good grades. I don't know of any graduate that didn't find a job. So this is the other way around. Yeah. I can only tell every graduate found a job, and you told me you have this big gap. Yeah. So obviously we have to do something about that.
Obviously we have to, and they found a very well-paid job, if I may imagine. So your curriculum, they also need an internship, a compulsory internship that they have to do with an industry. Do they not?
As a bachelor, they have to do these internships. In the master course, this is only for 3 semesters. So there's 2 semesters of theory and 1 semester of this practical work of the master thesis. And the master thesis usually is about 5 months, and they used to do that in the industry.
When you started your career in automotive, functional safety was not there, or it was not as matured as it today. Can you tell us a little bit about how things were dealt before functional safety was standardized, or where is the beginning of functional safety?
Well, functional safety, of course, was long before that, long before automotive safety was there. Functional safety came into contact, especially in space, aircraft industry, medicine. So all these parts were very deeply involved with functional safety. For example, spacecraft Challenger, the accident, or if you talk about Bhopal, this was said to be the beginning of functional safety. And especially in aircraft or space industry, functional safety became very important. Some standards were introduced to get this functional safety under control. This was introduced in a vast place of different subjects. For example, of course, the nuclear industry, then also vessels, firing vessels, the industry, and medicine, of course, then agricultural industry, and the mechanical part, the automation.
How was it when it was actually first vastly applied to the automotive industry? So you had by that time a lot of lessons learned from avionics, space industry, medicine industry. How matured was it back then when automotive industry started functional safety, and where is it today? How far have we gone in the automotive industry?
Well, at the beginning of automotive industry, you had to deal with electrics. So you had switches and relays in it, but by the time the vehicles, or also trucks, were equipped with electronic control units. And these electronic control units are small computers. By the time the vehicles were equipped with these ECUs, and even more ECUs, today a normal vehicle has about 80 to 100 computers in it. So there's lots of possibilities for faults that can cause hazards. And this has to be dealt with somehow. And by the time this standard ISO 26262 was created to get a clear way to get the things of functional safety managed in vehicles.
Fascinating. So we have talked about what was 20 years before. Automotive industry is facing, or in the verge of facing, the biggest disruption in the last 50 years, which is driverless car, autonomous vehicle. Now, if we want to look, project our imagination in 20 years in the future from now, and ask you, how do you think functional safety should develop, and practically, what do you also think? Do you think we were in the right track in terms of autonomous car and in 20 years down the line?
Well, there are very different opinions. There's, for example, the initiative 2025 AD. So that means, or is to say, in the year 2025, there should be cars driving in autonomous mode. Other people think this won't be possible until 2050. And I said 50, not 15. That's long ago. Cars have to be equipped with lots of assistance systems, with a vast variety of assistance systems. And all these have to act together somehow. Because one main thing is to get the car stopped. This can be handled today. You see that with an initiative for trucks. They have to get this fast stop and autonomous stop. Severe hazards occur when trucks run into these traffic jams there. These assistance systems should be installed in these trucks by legal requirements. But of course, it takes time to get these things installed, and they must be safe. There's one thing, they should work when it's needed, but of course they should not act if it's not needed. They shouldn't stop without any notice. And this must be handled by the electronics in very short time and safely. And this is one example that functional safety deals with. And the one thing is that the electric and electronic units are equipped with hardware and software that control these safe actions. And the second thing is that the safety management of all surrounding activities, this is called the V model or life cycle, that all these activities are maintained and done in a proper way. And that's a good thing that standards exist.
So is this standard, do you see a need of the standard to incorporate extra features or requirements due to the fact that we want to move toward autonomous vehicle within 2025 or 2050? The time horizon is debatable. However, when we see that within several years, the Google project, when they started, the LiDAR was $250,000, and today the LiDAR costs $75. So if we see this drastic development, there is a good chance 2025 aim is even realistic. So that's a short span of time horizon, and at the same time, the current standards, which is meant for a human-driven car, has to be incorporated into an autonomous mode. Can you tell us a little bit about the development in ISO 26262, for example, in that regard?
This standard is now released since 2010 and becomes a second edition 2018. There have been some improvements since the last standard, since the last release. We have motorcycles included. We have some part in it that includes the special electronics devices, and we have improvements in software parts. But there's a new standard coming up that's being worked about right now. It's called SOTIV, the safety of the intended functionality. That means you get a hazard without a malfunctioning. So, for example, the car or the assistance systems works as intended, and though it works as it should be, as it should do, a hazard will occur. And this is one thing that has been found by developing these assistance systems. So we have to extend the standard to this SOTIV part, and this is being worked on right now.
How about security? As we know that security will have direct consequences to safety, and when it goes to autonomous vehicle, the consequences are even more severe. So how do you think the industry is dealing with that, even in your curriculum, in your University of Applied Science Kempten's master's program curriculum? Is that included? How are you going about it?
Well, right now this curriculum in the master courses of Advanced Driver Assistance Systems and the second Automation and Robotics, we included functional safety because people found out it was very important and severe to include it. The first time I presented this course 2 years ago, I asked students why did they go to this course? What was so interesting about it? Isn't it boring usually? I thought it would be boring because it's mainly project management or dealing with standards. And there were about 30 students, and nearly all of them said we did work in the industry already because they had the bachelor's degree already, and they said everybody there in the industry said functional safety is important, but most of them couldn't tell what it is. So this is one point. Functional safety is important, but especially in the automotive industry, functional safety without security can't be done. You need security to get safe systems.
Do you also offer security courses in your curriculum?
I introduced one lesson especially with embedded security. And to get specialists in these courses, I invited Hassam Akram, for example, with his company Matrickz, to this course, and he held a lesson or one lecture of functional safety, which was very interesting, and students were very excited to hear about the things that are happening in industry, especially in this cybersecurity part.
Yeah, that was very kind. Yes, it was also a very exciting experience for me. We want to continue doing this, as in Matrickz. As you know, we are specialized in safety and security. The idea is to bring the safety and security together, because we have a lot of companies, they deal with functional safety. A lot of companies, they work on security. However, here what we do is what we want to try to bring this together. So what I feel is, this is again a question to you, Rolf, that as you said, the functional safety life cycle. I can see that there is practically existing security life cycle. Yeah. The term functional security life cycle is not quite there yet, and there is also not a very harmonization between a very good harmonization, I should say, between the safety people in the industry and the security people. What's your advice? How can we actually bring these two together more so that things work more in a harmonious fashion?
There is a standard that's called SAE, Society of the American Engineers, SAE 3069, that talks about this life cycle of security. But it's just a guideline right now, so you can't do real architectures with it. And it's set up like the ISO 26262, with the life cycle management, with a kind of V model, and you have usually the HARA, it's the hazard analysis and risk assessment. In the functional safety part, and in security you have the TARA, or hazard is replaced by
threat.
Threat, right. You have similar mechanisms, but you can't apply them equally, because there's the problem of possibilities. You can do probability management in functional safety, but when we talk about threats in security, it's very difficult to talk about probabilities, because this is done intentionally. You can introduce probability to some aspects, to some parts, but you have to deal with it completely different. And there's a standard, or a public available standard, released by the end of the year 2018 or beginning 2019, PAS 21434, for cybersecurity, and that deals with embedded security.
Rolf, you mentioned one guideline and one publicly available standard. SAE 3061 is the guideline, and PAS 21434 is the publicly available standard. So these standards are not yet legally obligated to be applied. And can you kind of tell us that what is the roadmap? When can we expect these to be really compulsory to be applied in the industry?
So maybe I should straighten something up. The ISO 26262, even this standard, is not legally
required.
What is it? Required, yes. Only the machinery standard, this is required. It's the ISO 13409, but the SAE 3061 is just a guideline which will never become legally, especially as it is an American standard, but it can be used as a guideline maybe to produce other standards, or to look at this topic, cybersecurity, right now, to see what might be going on in the future. And this PAS 21434 is meant to become a standard. Maybe it will be published by the end of the year 2018 or beginning 2019.
As
a public available standard. And as an ISO document, maybe even later.
What is the difference between a PAS and an ISO document?
An ISO document is harmonized by many organizations and of course the industry, and the industry also works in this PAS, but it doesn't have that rank of an ISO standard.
So it's a pre-version of something that's mature.
It's not a draft, it's just before that draft.
So there is a chance that the PAS will evolve to become a ISO document.
Could be, yes.
Right now we have 3,300 due to car accidents in Germany, right? So
Fatal
accidents. So with autonomous vehicle, with safety security roadmap in place, what's your prediction? Can we somehow reduce this number?
I'm sure that this number will be reduced, but it depends on how fast all these measures will be introduced, and these assistance systems are introduced and are fault-free, or not fault-free of course, but less in faults. The major problem is the sensors conceiving the environment. So the environment, the traction of all the surrounding happenings in a traffic situation, that is very complicated. And many of these situations can be handled by electronics and by software. But there are special situations that can't be handled by now. And that is now the problem, where humans are always needed. Right now, you know that there are different levels in the driverless autonomous situations. We do have 6 levels from 0 to 5, where 0 is complete driver responsibility, up to 5, where there is complete autonomous driving. And there are levels in between, and all these autonomous cars we have nowadays, or saying they are autonomous, are right now on level 2. And all manufacturers are now trying to get the cars up to level 3. And level 3 means they can drive partly autonomous, partly on special kind of streets in special situations.
I really like your optimism that you're sure this number is going to be reduced. And this is a good point to end with this hope and optimism. And I cannot resist quoting Chancellor Merkel when she said that in 20 years you will need special permission to drive a car. And we hope that what you just said, that you're sure this number is going to go down, this number 3,300 goes down by 5, 10, 15, 20 years, and we'll be driving safer autonomously or partially autonomously. Thank you very much for watching. It was Professor Rolf Jung from University of Applied Science Kempten. If you have liked our show, please feel free to write comments or write to us at podcast@matrix.de.